Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 17B Part 1 assignment. First one we're going to take a look at here is number 2. Construct a Voronoi diagram for the sites A and B. So let's do that first here, and then we'll get back to the second parts, B and C. So A is at -2, 5. So there's site A. And then site B is at 4 and 3. So here's site B. Okay. So we got to construct our Voronoi diagram. So that means we got to come up with the line that goes through that. So what we really want to do is find the midpoint, right? So let's see. We're gonna to get down to B. That's let's see. Let's do. Just trying to. We can, what, let's just use the midpoint formula. Let's make our life easy. So -2 plus 4 over 2 and 5 plus 3 over 2. So that gives us, what, 2 over 2, which is 1. And then 5 plus 3 is 8 over 2, which is 4. So we get the midpoint is at 1, 4. So we know that the line is going to go through here. Okay, the slope from A to B is going to be 3. So slope is going to be 3 minus 5 over 4 minus -2. So that's 4 plus 2. So that gives us -2 over 6, which is -1/3. So that's the slope of this line. But we want the perpendicular slope to that. So perpendicular, we flip it and switch the sign. That turns into a slope of 3. So we'd want to go up 3 over 1, which is roughly going to be there. Let's go down 3 over 1, and maybe even down 1, 2, 3 more over 1 more. And that will give us, now we can draw our perpendicular line that goes right through that. So there's another spot right there. So I'm going to simply start right there. Draw myself a nice little line there, and there is our Voronoi diagram for just the two sites A and B. Okay. Part B, find the equation of the Voronoi edge. Good news is we already have the midpoint and we already have the slope, so simply we're just going to plug that into our point slope formula, which is y minus y1 equals m times x minus x1, right? So we do y, always use the midpoint. Don't use either of these points because the midpoint is the point that's on that line. So we go y minus 4 equals 3 times x minus 1. Y minus 4 equals 3x minus 3. Add 4 to both sides, and we get y equals 3x plus 1. So we can do it that way. We can also look here and say, oh, look, the y-intercept's at 1. So it's going to be plus 1. And then we knew that the slope was up 1, 2, 3 over 1. So the slope is 3x plus 1. You could do it that way, too, without even having to plug it in, since you already have the graph. Okay? Part C, verify that the point -2, -5 lies on the Voronoi edge. That means it would have to lie somewhere on this line here, right? So if that is going to lie on this line here, I'm going to go over here for C, part 1. What we're going to do is we're going to plug -2 in for x, for the x, and plug in -5 for the y and see if it equals. So does -5 equal 3 times -2 plus 1? -5 is -6 plus 1. -5 indeed does equal -5, so we have verified it. Okay. Also, verify that the point -2, -5 is equidistant from both A and B. So let's just graph it so we kind of get an idea. -2, -5 is this point right here. So we want to find the distance between these two points. So we can use the distance formula, or we can use triangles. Let's see, on the last one I think we just used triangles, so let's mix it up a little bit. Distance is going to equal the square root of our x's minus each other. So let's do, like, say, it doesn't really matter if it's x2 minus x1 or x1 minus x2. Square them both and add those to the y2 minus y1 squared. So in this case, let's see, this point here is at -2, -5. This is at -2, +5, and point B is at 4, 3. So we can simply just do the distance formula a couple times and show that they're the same. So we got square root of, let's do, say, that's site A, that's site B. Let's call this C. Okay, so this is going to be the distance from A to C. So we will do the difference of the two x's. So we'll do -2 minus -2 squared, and then the difference of the y's is -5 minus 5 squared. So this distance here is going to be 0 plus -10 squared, which is 0 squared is 0, -10 squared is 100, and square root of 100. So the distance of that is going to be 10. So from A to C is 10. And then if we do, let's see if we can fit it on here. I think we can. B to C is going to be square root of -2 minus 4 squared plus -5 minus 3 squared. And it doesn't matter which one you start with, because either way, when you end up squaring it, they'll all end up being positives anyway. So distance is going to be, we got -6 squared plus -8 squared, right? So that's going to be -6 times -6 is 36. -8 times -8 is 64. So the distance is going to be the square root of 100, which is also 10. Okay? And that there shows that it is equidistant from A and B, because both the distances are the same. Okay? Okay, moving on to number 6. This map shows the locations of Pablo's pizza stores in the city. When customers ring Pablo's Pizza, they are automatically transferred to the nearest store. Construct a Voronoi diagram for these sites. Okay, so we got A, B, and C. So we really just want to find the midpoints of each of these. We can go through and do the midpoint formula, or you can try to do this in your head, which would also work. So this is 1, 2, 3, 4, 5. So half of 5 is 2.5. So 1, 2.5. And this distance from left to right over here is a distance of 1. So that's going to be, we're going to be right in the halfway point there. So there's our midpoint. Okay. And then what we're going to want to do is we're going to want to, you know what, hold on just a second here. I'm just putting this on a different layer so that I can end up erasing some of this later on, because that's probably what we're going to need to do. So there's our midpoint. We know the slope from on this line here is 1, 2, 3, 4, 5 over 1. So the slope from A to B is 5 over 1. So therefore our perpendicular slope will equal -1 over 5. So from there we're going down 1 over 5, which is not going to work very well. So we're going to have to go up 1 to the left 5. 1, 2, 3, 4, 5 to right there. And we can go up 1 more and over 1, 2, 3, 4, 5 more to get that point there. So then we can draw ourselves a nice line here that goes through all of that. So there's our edge that goes between A and B. And then we'll also want to do, say, the edge between B and C and the edge between A and C. So B and C, it's down 1, 2, 3, 4. So halfway is 2. And then it goes over 1, 2, 3, 4, 5, 6, 7, 8. So half of that is 4. 1, 2, 3, 4. And we're going to know the other. So there's our midpoint right? So really it's going up 1 over 2, up 1 over 2. So if we're up 1 over 2 for this line here, we want to find the perpendicular to that. So the perpendicular is going to be -2. So we're going to go down 2 over 1, down 2 over 1, can't do that anymore. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So we've got that, and we've got, draw ourselves a nice straight line there. Right? And then, so that's B and C. Now we want to do the same thing between A and C. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So half of that's going to be 4.5. So 1, 2, 3, 4.5. So that's right in here. And then over is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be over 4.5 as well. 1, 2, 3, 4.5. So there's our midpoint. I'm going to go back and erase that because we don't need that anymore. So there's our midpoint between A and C. And then what we're going to want to do is we're going to want to find the slope there, right? So really it's up 9 over 9, right? So 9 over 9 is really just 1. So then that means our perpendicular slope is going to be -1, right? So we'll go down 1 over 1, down 1 over 1, so forth and so on. And we'll do these all the way up as well. So really it's going to be, there we go, this line here. So now we have all of our lines. Now we just have to go through and figure out which parts to erase. Okay, so B is going to be this whole section in here. So we got to get rid of this line right there, right? So we want to erase this line right in here. So we're going to get rid of all of that. So hopefully that makes sense, because you're like, look, okay, we've got all these here are equidistant from A and B. All these are equidistant from B and C. So we don't need this part in here because that's not separating anything that we need. This is the part up here that we need. So that means we're going to want to get rid of this part of the line and get rid of this part of the line as well. And that should be our Voronoi diagram. Because again, this line right here wasn't there's no site in between those, so we don't want to have those lines. So there's our Voronoi diagram for these two things, for these three sites. Amanda is equidistant from all three stores. Where does Amanda live? She's going to live right here at that vertex, right? So she's going to live at -1, 2, 3, 2. And then how far is Amanda from each store? So if she's the same distance from all the stores, all we really have to do is find the distance to one store, right? So we did the distance formula, and we've also done the triangles. I kind of prefer the triangles, so I'm just going to draw a triangle here. All right, so there's a little triangle. We're trying to figure out that distance there, right? So we know that this is 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, 7. So the distance Amanda is from each store is going to be, well, let's really do this. How about this? D squared is going to equal 4 squared plus 7 squared. So that's 16 plus 49. That's going to be what? 49, 59, 65 is D squared. So we square root both sides, and D is going to be the square root of 65. And I don't like it when we have a square root number, so I'm going to actually just figure out what that is. Square root of 65 gives us 8.06. And what is this in? Is this in... it doesn't... Oh, kilometers. 8.06 kilometers from each store. Okay? Okay, we're going to take a look at one more here, number 7. Part A, explain why this Voronoi diagram must have an edge missing? Well, it's got an edge missing because there's nothing separating A and D. So that's they're in the same cell over here, so that can't happen. Copy and complete the diagram and find the equation of the missing edge. Okay, so good part about this is we know that this line's going to have to be right here at this vertex, right? Because there's obviously a vertex right there, and we're just going to have to basically go straight through there. So we're going to have to find the equation, but first let's find, the easiest way is going to be to find the midpoint, right? So we're 1, 2, 3, 4, 5, 6 over 2. So half of 6 is 3. Over half of 2 is 1, so it's going to go right through that point right there. We already know it's starting at that vertex right there, and so we just put it right through that point there. And there's our line. So find the equation of this line here. Really, we've got 2 points. We know that the slope is 3, right? So it's up 3. Sorry, not 3, but 1/3, because it's up 1 over 3. So our m is 1/3. So if we know the slope, all we really need to do is just plug in 1 point to figure out what our y-intercept is. Also, you could hopefully figure out that you say, hey, we're up 1/3 over 1. Then it's going to be right here at 1 1/3, right? So our b equals 1 1/3. If you weren't able to figure that out, again, you can plug in the slope is 1/3 and the point -1, 1. -1, 1 into the point slope formula. Y minus y1 equals m times x minus x1. Y minus 1 equals 1/3 times x minus -1. So we get y minus 1 equals 1/3 x plus 1/3, and then you add 1 to both sides. And there's our y equals 1/3 x plus 1 1/3. Okay, so there's our formula. But again, from back here, you simply could have gone y equals m, which is 1/3 x plus b, which is 1 1/3. You could have done it that way as well. Okay? Okay, that's all we have for the 17B Part 1 problems. If you have any further questions, please feel free to ask in class. Thanks.